we ended the last lesson with this. With this problem, gave this to you as a challenge to do on your own, to sit there and multiply it all out, expand the whole thing and see what you get. You did it, right? You did? You got it right there in front of you? Oh, you don't? Pause button. You got to hit the pause button. Pause button's right there. It's right there. Hit the pause button. Multiply it out. You hit the pause button, right? Yeah. Good. Okay, you got it now. You multiplied it all out. It's great. So what we're going to do here is I'm going to multiply it out too. You're going to watch. You're going to see how I do it. And then we're going to compare my answer to yours. Right? And hopefully they'll be the same. And that'll probably mean we're both right. But if they're different, then one of us is wrong. And I hope it's you, because if I'm wrong, I'm going to have to shoot the video over again. And I got hundreds more videos to do. And I don't want to have to do this one again. So let's see. Where are we going to start with this? Well, we're raising a binomial to a power, so we'll use the binomial theorem. Well, we'll get rid of this. We'll just wipe that right off the board. Oh no! We erased the formula. How are we going to do it? The formula's gone. How can we possibly do this without the formula? We don't need the formula because we know why the formula is true. And we'll use that to do the problem. I'm going to write it again a little smaller because I don't have nearly enough room to write it all that big. Just going to write a little bit smaller and see if we can do this without copying the formula. We've got 1 minus 3b squared raised to the 4th power. What does that mean? That means I have 4 of these. I'm multiplying them all together. And this is how I think of these problems. This is how I think of raising binomials to powers. I don't write this down every time, of course, but this is what's in my brain. If you can see inside my head, you see these all laid out, getting ready to get multiplied together, and I think, okay, what sort of terms are going to come out of this? When I multiply all these together, well, I can take a 1 from each one of these binomials, and that'll give me 1 to the 4th. You know, so I don't write that 4 choose 0 in front from the binomial theorem, because I know that's 1. There's only one way to get a 1 from each of these terms. So then my next term, well, for my next term, I can take 3 1s and a minus 3b squared. And I'm wondering if maybe the first time you multiplied this out, you forgot about these minuses. You got to remember the signs. You have to watch out for these. You have to remember the minus there. So if we take 3 1s and a minus 3b squared, well, we'll have 1 cubed and then the minus 3b squared. Got to remember the minus. You're going to get the sign wrong in the end. Now, this isn't the only way to do this. 1, 1, 1, minus 3b squared. I could take the minus 3b squared from here and take the ones here, here, and here. Or I could take this one, or I could take this one. So I see that I have 4 choose 1, or 4 binomials, and I'm only choosing 1 to take the minus 3b squared from. So there 4 choose 1 of these pop up. And next up, I'm going to take 2 1s and 2 of the minus 3b squareds. Well, there are 4 choose 2 ways for me to choose those, to choose the binomials to take the minus 3b squareds from. I'm taking 2 1s and 2 of the minus 3b squareds. And now you see why I chose to write this again smaller. I'm running out of room. Next up, I'm going to take only 1 of the 1s and 3 of the minus 3b squareds. And again, notice I'm keeping my minuses here. So I'm going to take 4 choose 3. I just need 1 1 and 3 of these. And then last, I'm going to take a minus 3b squared from each one. There's only one way to do that. And I'm raising that up to the 4th. Now I have it all laid out. Now I just turn the crank, pound all this out. 1 to the 4th is just 1. 4 choose 1, well, that's 4 times 1, well, that's just 1. And then I have my minus 3b squared, so I'm going to have minus 12b squared here. All right, then over here, 4 choose 2 is 6. Minus 3b squared, I'm squaring that. That'll be 9b to the 4th. Now notice I'm squaring the 3 and the b squared. Negative times a negative is a positive, so here I've kept the negative. Here the negative goes away because I've squared it away. Then next up I have, let's see, that's 4. 4 choose 3 is just 4. Minus 3b squared, this whole thing cubed. I'm going to have to keep that minus again. b squared cubed is b to the 6th. And then my last term, well, minus 3, when I raise that to the 4th, I get 81. And then b squared up to the 4th is b to the 8th. And now I can just, now I've got the whole thing here. I go 1 minus 12b squared plus 6 times 9 is 54. 54b to the 4th. 4 times minus 27. Well, you double minus 27, you get minus 54. Double that, you get minus 108 b to the 6th. And then we have our 81 b to the 8th. And we can test this. We can test this by picking specific values of b. We can put in b equals 0. It's not very interesting. That becomes 1. All of these go away, so that doesn't really test these coefficients out here. But if I put in b equals 1, then I have 1 minus 3, which is negative 2, raised to the 4th, is 16. Well, do I get 16 down here when I put in b equals 1? Well, let's see. If I put in b equals 1, I have 1 minus 12 plus 54 minus 108 plus 81. So how will we do that? Well, we can add the 81 and the 54. That's 135. 135 minus 108 is 27. 27 minus 12 is 15. 15 plus 1 is 16. So sure enough, I put in 1 in here, put in 1 in here, I get the same thing. So I'm pretty confident I'm right. Is that what you got? Yeah, that is it what you got? You sure? Check it again. Make sure you got all these powers. 2, 4, 6, 8. Didn't forget the squareds in here. All right, good. So you got this too. Now we see here, did you see me write the binomial theorem down? No, I didn't have the formula on the board. Didn't write it down for n equals 4. I just thought about why it's true, and out popped the answer. Now next up, we're going to see some problems in which understanding why the binomial theorem is true, like we did here, will get us the answer much faster than writing down the whole formula and cranking all the way through it. And then you'll see why the journey of proving the binomial theorem and seeing why it's true is much, much more important than the destination of simply knowing the formula.